Okay, Zach, we started going over stuff for section 8.1 logs, and we're doing the graphing of A logs. And so I started going, and then they're like, oh shoot, you should need to record. So here we go. This little green guy, this is a graph of what 3 to the x power is. I just randomly graphed him. I just said, put this in the corner, 3 to the x power. This is just all made up. I'm doing this on the corner of page 401. Okay, 3 to the x power is this green guy. We did kind of a little bit of a table and we graphed him, and we said he has a ha right here at 0. And then what we did is I said, okay, the opposite of 3 to the x power, or the inverse, is log base 3 of x, okay? And so we're graphing logs now, and all you do is you take these coordinates, 0, 1, 1, 3, 2, 9, and you switch them around. So it's 1, 0, 3, 1, 9, 2, and this is my log function. So my log function looks like a reverse L, kind of, like a flipped L, okay, where he's going to have a vertical asymptote, so he's not going to touch here. Let's talk about domain and range real quick while we're on it. Domain, range. Okay, domain is left and right. Hold on, just wait. We're talking logs, so we're talking this guy right here, okay? Whoop. Okay, left and right. Will he go to the right forever? Hold on. Will he go to the right forever? But he won't go to the left forever because he's like butt up against this dotted line right here. X is greater than 0. Gosh dang it. Why is he doing that? X is greater than 0. Is it equal to 0?
No.
Hold on. Un momento, por favor. Okay, X is greater than 0. He's not going to touch that guy. Okay, what about range, up and down?
All reals.
He'll be all reals. So notice that he's like, he's like the opposite of an exponential function. Like usually domain is all reals and range is y is greater than 0. Now they're opposites. Yes, Lauren?
So when we graph, we're going to have to put, it's going to be an exponential function and we have to switch it to log.
No. They will say, kind of.
Well, because we can't put it in our,
What's the homework?
All right, just wait a second.
We can't put it in the numbers like solve per se.
Right. Just hold that thought for just a second, okay? Let's go to this guy. Go to example 5. We're going to graph example 5 real quick. I think that's where we left off, maybe. Yep. Go to example 5. Let's graph him. Okay? All right, so I'm going to graph him over here. We're graphing log base 6 of x. Shh. Here we go. We're almost done. We're graphing log base 6 of x. Okay, what's the opposite of log base 6 of x? What's his exponential function? 6 to the x power. So kind of be thinking of that, all right? Now, this log is going to do one of those. All logs do one of those, right? Where is he going to cross right here at? 1, 0, okay? Now, let's figure out where the next spot is. If I plug 1 into, gosh dang it. If I plug 1 into here, 6 to the first power
It's still 6.
is 6, okay? So this would be 1, 6 up here, but now it's going to be 6, 1, right? 1, 2, 3, 4, 5, 6, 6, 1, right there like that, okay? If I go to 2, 6 squared is 36, right? So this would be 36, 2, like all the way up here, and he's going to go like this. Whoop, like that. Okay? Yeah? Now, the bigger this number, I kind of talked about this yesterday, the bigger this number gets, what happens to my graph? The like steeper it gets. So like this guy might be like 2 to the x, or log base 2, right? This guy is log base 6. This guy would be like log base 10. Like really short and like really in an L shape. It's more of a C shape the lower the number goes. It's more of an L shape the bigger the number goes, okay? So that's what he will look like. Now let's talk about B. Do we have a B? Yeah, we have a B. This guy, ooh, log base 1/4. What is his exponential function?
1/4 x.
1/4 to the x power. Okay, so if we go to graph 1/4 to the x power, first of all, this guy is a, what kind of function? An exponential decay. He's going downhill, right? Okay, so he's going to go like this. He's going to go downhill. So, as far as my log goes, this is weird. Exponential decay functions. This is weird. Ready? Instead of him being like this, he's going to go like this. Yeah? His little tail is going to like approach X on the top side. You see him?
Negative is on the other side.
When it's negative?
Yeah.
What do you mean when it's
When
negative?
is it going to go on the other side of the line?
like when it will like flip over to here?
Yeah.
That will be if we have like, for an exponential function would be like 1/4 to the negative x power. Here it would be like log base 1/4 of negative x. Okay? This negative log base 1/4 of x, that's going to flip him down. But like if I put a negative here, that's going to flip him over. We probably won't deal with that a whole lot. So that's a little bit confusing. Okay, so don't listen to that. Don't listen to that. Okay, next, let's do this guy. Let's graph him. Example 6. Okay, and we're almost done. Example 6 and example 7. Let's go example 6. Let's talk about how to graph this guy. Log base 10 is my base. Okay? All right, let's talk about what some of these numbers do. How is the 3 going to move him? To the left 3, because plus means left and minus means right. So left 3. What's the minus 1 do? Down 1. Okay? All right, what's this 2 going to do? Vertical stretch by 2. So it's just going to make him like more narrow, right? Okay? All right, so normally my log function is going to cross here at 1, yeah? Okay? And he's going to do one of these. Whoop, like that. Okay? Maybe, ish. Okay? But I am moving him how? Left and down?
Yeah.
Left? How much?
3.
Left 3 and down 1? Left 1, 2, 3 and down 1. Oh, look at that. Yeah? Okay? So, your vertical asymptote was here at 0. If I move him to the left 3, he's now going to be at negative 3. And now I can just graph my function. What does the vertical stretch of 2 do?
It makes it go shorter.
It just like makes the arch different, right? Yeah, it's going to make him a little bit taller, right? But I don't really care about that. My dots are going to be the same no matter what, okay? So the vertical stretch is not going to change your domain and range. It's not going to change your asymptote and not going to change where that dot is located, all right? So left 3, down 1, that's usually the point that I plot and then I go, okay? Do they ask for domain and range? No, they just say graph it. There you go. That was example 6. That was really quick. Okay, go to example 7. Compare the log functions. Those two. Oh, okay, right here. So this guy is the graph of log base 10 of x minus 2. How is the minus 2 moving him? Right 2. Okay, so normally he would be, don't ignore the blue one that's there. Okay, normally he would be going like this, but if we go to the right 2, he's actually going like this. Okay, so I'm going to get rid of the first one. Whoop. They want me to compare that one and the blue one that's already there. What's happening with the blue one that's already there?
It's going
He's flipped. What is this guy? Like, what would his equation be? Negative log base 10 of x, not moved any direction, right?
Plus 2.
No, the plus 2 is only on the other one. Over the y-axis would be the negative on the x. Over the x-axis would be negative out in front. Okay?
Wait, so
The one he drew.
The one that I drew is log base 10 of x plus 2. No, minus 2. Minus 2.
So it's opposite.
Okay? Yes, it's opposite. This guy is the one that I drew in the blue black. This guy is just flipped.
negative in front goes over the x, negative behind the numbers
Goes over the y. Yep. Okay? So, they're saying consider the graphs shown. Graph them. Compare the end behavior. Oh, look at what they did. Is my graph wrong? This is the one I graphed. This is the one that they graphed. Oh, theirs is going by 2s. Okay, so keep that in mind. And theirs looks a little bit more of an L shape just because it is going by 2s. Okay, so this one we're comparing to this one, the end behavior is just going to be like opposite, right? Okay, one is going up on the left side, one's going down on the left side. Okay, whatever, compare. Let's go to 8. Last one. Just wait, let's go to 8. Last one. They say log base 4 of x, what have we done to him? Okay, log base 4 of x, what's the dot that he should go through?
He went left 1.
He went up 5.
He went left 1 and up 1.
He went up 5.
He only went up 1, 2, 3, 4, 5. He only went up 5. That's it, right? So my log base 4 of x plus 5, that's my new function, right? He's only here and he's just moved up 5. That's all. Okay? So this is rewriting what the function looks like. Log base 4 of x plus 5. Good?
Sure.
Woo! Where did he go?
Whoa, it deleted.
We undo. He's gone.
What?
There he is there again.
36.
That's a lot.
Okay, so you should have from yesterday, hopefully, 1 through 12 and then 14 through 22. 1 through 12 is just doing the switcheroo. They should be really fast. 26, 30, 34, 36, those are the new ones that you add today. And they are graphing. Yes, dear. Okay?
Number 34.
Stick it in the thing.
Literally push.
It's
all you gotta do.
graphing.
I got it. The
It
yesterday
really
stuff.
does.
You can figure out 34. That one's not hard.
Easy.
34 is not hard. You haven't even looked at it.
I'm dumb.
Okay.
It's plus.
Can we graph 36 on one of these graphs?
That's fine. Yeah, if you want to.
And then
Just make a note, like, of it so that I know. Yeah, yeah. Okay? So Jacob just said if you don't want to graph on an extra sheet of paper, number like whatever it was, 26. Do I make you graph 26? 26, if you want to graph 26 on like 29's graph or whatever, just make a note of that and then you don't have to get graph paper. Make sense?
Yeah.
Okay, sure. That will work. All right, anything else? Okay, hop to it. Oh, I gotta